Hiya, have you started revising the differentiation topic and you're confused at the basics? How do we differentiate a basic polynomial? And why? Why are we doing this? Well, then you've come to the right place. Hi guys, it's Charlotte here from Studentium, and I am here to make sure that your maths and science revision is as stress-free and simple as possible. Make sure you subscribe to get all of your weekly videos in your inbox and you don't miss out. Now, let's check out this video. All right then, let's do this. Let us just check out the basics of how we differentiate polynomials. So that's things of the form of x to the n. All right, so first things first here, I just want to remind you, what is actually differentiation? Like, why are we doing it? And what differentiation actually does is it tells us the gradient of a curve or the rate that a curve is changing, all right? And this is something that's going to be so important over your whole A-level. You're not getting away from it. You really just want to ingrain in your mind. Differentiation means gradient, all right? So in terms of notation, when we do differentiate things, we will know we're doing it because we get this notation dy dx. Notice that's a little bit like when you've done gradient at GCSE, and we know it's the change in y over the change in x, or you could think of it as the difference in y over the difference in x. So that's like dy over dx, you see? So this, you might hear it referred to as the gradient function, the derivative, the differential. There's so many different ways this could get referred to, but they all mean the same thing, that we need to differentiate. Okay, in fact, there's a whole nother notation as well, because we don't always write equations as y equals something. Sometimes we write it as f of x equals something. And in that case, how would we know that we're going to differentiate? There's no y to say dy by dx. Well, in that case, what we do is we use the notation f dash x to represent that exact same differential. It means the same thing, it's just a different notation. So let's quickly summarize that then. So if our function is y, then our gradient function or our derivative or our differential, however we name it, would be dy dx. And if our function was f of x, then our gradient function or our derivative would be f dash x. All right, so how do we do it though? Okay, we've had a chat now about what the notation looks like. We've had a chat about what it means, that it gives us a gradient or a rate of change. But let's look at the actual facts that we need to know, all right? So if we had a function of the form y equals x to the n, then that would be dy dx in that case, would be nx to the n minus 1. Now, in English, what that means is you're going to multiply through by the power, and then you take one away from the power, okay? So if there was a number in front of it, so let's imagine it was ax to the n. Let's put that in words. Imagine it was 5x squared. What you would do is you would times through by the power of 2 and do 5 times 2, x to the 2 minus 1. So that would end up giving us 10x to the 1. But let's have a look at what it would look like with that function notation. Remember, we said that it's exactly the same. So if instead of y equals x to the n, it was f of x equals x to the n, we do the same action of multiplying through by the power and then subtracting 1 from the power. But instead of writing dy dx, we write f dash x. And this other fact here, ax to the n is just talking about we've got a constant in front of the polynomial, and you'll see it makes no difference. So we're still going to multiply through by the power and then take 1 away from the power, all right? So other little facts that might be really helpful. We don't always have like a physical power. It's not always like x squared, x cubed, x to the 4, x to the 5. Sometimes it's just x, isn't it? So obviously x seriously is, in reality, it reflects x to the power of 1. But an even quicker thing is just to know if y was equal to kx, so say 10x or something, then when you differentiate, you can just drop the x. Now, you can think of that in terms of what we learned previously, that you multiply through by the power and then take 1 away from the power. or you can just learn this trick. Okay, really handy. So if y was equal to, say, 10x, the differential would just be 10. If y was equal to 2x, the differential would just be 2, all right? Another really helpful one is if your y was equal to a constant, so there was no x there at all, it was just 5 or something. When you differentiate that, you simply get 0, all right? Really handy things. So let us have a go now at putting this into practice and seeing a few examples and see if you can do it. All right, so differentiate y equals x to the 7 with respect to x. By all means, pause the video here and see if you can do this one yourself using the techniques that we've said. If not, let's have a look together. So we know this general rule that when y equals x to the n, the differential, you multiply through by the power, then you take one away from the power. So we'll do that here in this case. Multiply through by 7 and then take 1 away from 7. We get dy dx is equal to 7x to the 6. Perfect. Then let's have a look at another example. All right, again, if you'd like to put this one into practice yourself, pause here, and then once you do it, check out my solution. So if y equals 8x to the half, then we're going to multiply through by the power, and then we're going to take 1 away from the power. Now be careful with fractions here, because when we subtract 1, it's easy to make silly little mistakes. But let's see this then. So we times through by that half, and then we're going to take 1 from the half. A half times 8 gives us 4, and a half minus 1 leaves us with minus a half. So dy dx here is 4x to the minus 1/2. All right, looking good. Let's try another one. Okay, so this one, notice that there's 2 different terms, and also it's written as f of x instead. So we'll be finding f dash x in this case. So when you've got more than one term, and this will happen often, I want you just to treat each one separately, okay? So no big deal. You're just going to first differentiate x to the minus 3 using our technique, times by the power, take 1 away, and then you're going to do exactly the same thing with 3x squared. You're going to times through by the power and then take 1 away from the power. So we end up getting here, for the x to the minus 3, we times through by minus 3, and then you take 1 away from minus 3. And you will end up getting, for that one, minus 3x to the minus 4. And then for the 3x squared, you times through by the power, you get 3 times 2, so 6. And then you take 1 away from 2, that power, and you're left with 1. So our final answer there is that f dash x equals minus 3x to the minus 4 plus 6x. Really common mistake is when there's a negative power and we take 1 away, our head just goes, oh, 3 minus 1 is 2. And in this case, it'd be very easy to have written your final answer as x to the minus 2 instead of x to the minus 4. So just keep that red flag in your head of, oh, this could definitely cause me an issue. So then let's try out the next one. So in this one here, we want to differentiate f of x equals the cube root of x. So to be able to do this, we need to remember back from GCSE that roots can be written as fractional powers. So the cube root of x can be rewritten as x to the power of 1/3. And that's really important for this question. So if it was the 4th root of x, then that would be x equals 1/4 and so on. So once we do that and we rewrite it, we can then use our standard rule that we multiply through by the power and then subtract 1 from the power. So again, a bit like the negative powers, we could very easily make little mistakes with this. So 1/3 minus 1 whole leaves us with our differential here. We've got f dash x equals 1/3 x to the minus 2/3, all right? So we've tried there a really good range of different differentiation questions. It'd be great for you to try some more by yourself. Before I leave you though, I just want to remind you of these couple of things, these facts that I just referenced, that back from your algebra GCSE times. If you don't know these like in your soul, then I would recommend you add these to a nice flashcard just so you've got it there as key facts that you can memorize and use in these questions. Well, great work, and I'll speak to you soon. Bye. Well, I really hope that you found that video helpful. make sure you subscribe, because every week we're going to have explanation videos and also exam style question walkthroughs on the topics that we've covered. So don't miss out. Okay, bye guys.